Hey everyone, and welcome back for another deep dive. Today we'll be looking at something you've probably seen countless times, but maybe haven't thought too deeply about the physics behind it. Pendulums.
And we've got some pretty cool resources for this one.
Oh yeah.
Yeah, we're using stuff from open educational resources and open source physics at Singapore.
Wow. Sounds like a mouthful.
Hmm.
But what's so special about these resources?
Well, they not only break down how these things work, but also show us how actual scientists use simulations to study pendulums.
Interesting. So it's not just about the pendulums themselves, but also about the way we learn about them.
Absolutely. And by the end of this, you might even find yourself thinking a bit more like a physicist.
Okay, I like where this is going. But before we get ahead of ourselves, let's back up a bit. What exactly is a pendulum? I mean, we all kind of know what a swing looks like, right? But what's the science behind its movement?
Well, at its core, a pendulum is simply a weight attached to a fixed point, free to swing back and forth.
Okay, makes sense. Like the classic example is a grandfather clock, right?
Exactly. Or think of a playground swing. And the reason it swings has to do with gravity pulling down on that weight.
Right, gravity, of course. But I feel like there's got to be more to it than just gravity, right? What makes it swing back and forth instead of just, hanging straight down?
You're absolutely right. There's this thing called a restoring force that also comes into play.
Restoring force.
Yeah. Imagine like an invisible rubber band pulling the pendulum back towards the center every time it swings out. That's the restoring force in action.
Ah, okay, I'm starting to see it now. So gravity pulls it down, this restoring force pulls it back towards the middle. It's like a constant tug of war.
Exactly. And the point where it hangs perfectly still, that's called the equilibrium point.
I see. So it's
Yep.
all about this balance between gravity and the restoring force.
You got it.
Okay, but how do scientists actually figure out how a pendulum's going to move? I mean, can they predict how fast it'll swing, how far it'll go, all that stuff?
Well, they use math to do that.
Math, huh?
Yeah.
Figures.
Actually, our source even shows how you can use math to predict a pendulum's movement, just like real physicists do.
Really? Okay, now I'm intrigued. What kind of math are we talking about here?
It involves something called Newton's second law, which basically describes how forces make things move.
Okay, Newton's second law. I'm vaguely familiar with that, but I'm going to be honest, math isn't exactly my forte.
Don't worry, we don't have to dive deep into the equations themselves. The main point here is that even something as seemingly simple as a pendulum can be understood and even predicted using math. It's pretty cool how math can help us decode the universe like that.
That's a great way to put it. I never really thought about it that way before. Now, speaking of decoding the universe, I noticed our source mentioned something called a pendulum simulation. What exactly is that? Like a video game for scientists or something?
Haha, it's kind of like that. Simulations are essentially virtual experiments. They allow scientists, and anyone else who's curious, to test things out on a computer without needing to build anything in real life.
Okay, so it's like a digital playground for physics.
Exactly. You can play around with different variables, like you can change the length of the pendulum, the weight, even the strength of gravity, and then see how those changes affect its swing.
So instead of setting up a real pendulum and timing it with a stopwatch, you could just change some settings on a computer and see what happens.
Exactly. It's super efficient and lets you explore all sorts of possibilities that might be difficult or even impossible to create in a real-world experiment.
That makes a lot of sense. I'm already starting to see how useful that could be for learning about pendulums and physics in general.
It is. And here's where it gets even more interesting. Remember how I mentioned our source comes from open educational resources and open source physics at Singapore?
Yeah, those names are definitely sticking with me. What's so special about them again?
Well, what it means is that these learning materials and simulations are completely free for anyone to access.
Wait, hold on. Free physics lessons and simulations for everyone. That's amazing.
It is. It really opens up a whole new world of learning for anyone who might not have access to traditional schools or, expensive textbooks.
I love that. It's like democratizing education in a way, right?
Yeah.
Making it accessible to anyone who's curious enough to learn.
You got it. And it's something I'm really passionate about.
Me too. I'm realizing that this deep dive isn't just about pendulums, is it? It's about so much more.
What do you mean?
Well, we're talking about the science of pendulums, sure. But we're also talking about the way we learn about science, about open access to education, about using simulations to explore the world around us. It feels like there's a bigger picture emerging here.
You're absolutely right. The pendulum is just one example. What we're really exploring is how we can use observation, theory, and simulation to understand, well, pretty much anything.
Okay, I'm listening. Break that down for me.
So first you observe something interesting, like a swinging pendulum. Then you develop theories to explain why it's happening, and often you use math to express those theories.
Right, like that Newton's second law thing we were talking about.
Exactly. And then you test those theories using simulations or experiments. And through that process, you gain a deeper understanding of how things work.
So it's like a cycle.
Oh,
Observe, theorize, simulate. Rinse and repeat.
exactly. And it's a cycle that can be applied to so many areas beyond just pendulums. It's a way of thinking, a way of approaching problems and questions.
Okay, that makes sense. But can we really apply this observe, theorize, simulate thing to, like, everyday stuff? I mean, how would that work with something like, I don't know, traffic patterns in a city?
That's a great question. And you know what? You absolutely can.
Really? Tell me more.
Well, if we were trying to understand traffic patterns, the observation part would involve collecting data, right? Like how many cars are on the road at different times, where they're going, how fast they're moving, all that stuff.
Right, so you'd be gathering all the info about how the traffic pendulum is swinging, so to speak?
Yeah, exactly. Then comes the theorizing part, where we start to ask why. Why are we seeing these patterns? What factors are influencing the flow of traffic?
Like rush hour,
Yep.
road construction, people trying to find the best coffee shop in town.
Exactly. Maybe there are bottlenecks at certain intersections, or maybe weather patterns affect people's driving habits. We try to come up with models and theories to explain what we're seeing.
Okay, so you'd be using those observations to build a theoretical framework for understanding traffic.
Yeah.
But where does the simulation part come in?
Well, once you have a theory, you can test it out using a simulation. You could create a virtual model of the city's streets and traffic flow, and then see if your theory holds up. You could even experiment with different scenarios, like changing the timing of traffic lights or adding new roads, and see how those changes impact the overall flow.
Wow, that's pretty amazing. It's like you're taking the scientific method, which we usually associate with lab experiments, and using it to understand everyday life.
You got it! And that's one of the most powerful things about this approach. It's not limited to scientists in a lab. It's a mindset, a way of thinking that anyone can use to learn and explore the world around them.
Okay, my mind is officially blown. We went from talking about swings to understanding traffic patterns to, well, who knows what else. So what you're saying is that anyone, even without a fancy science degree, can use this observe, theorize, simulate approach to learn and explore.
Absolutely. All you need is curiosity and a willingness to try things out. And thanks to resources like open educational resources, the tools and information are readily available to anyone who wants to learn.
Okay, simulations are great and all, but at some point, don't we need real-world experiments too?
Yeah.
To actually see how things work in the real world.
Of course. Simulations are powerful tools, but they're just one piece of the puzzle. Real-world experiments are still essential for validating those theories and making sure they actually hold up in practice.
So it's about finding a balance between the virtual and the real.
Absolutely. It's about using all the tools at our disposal to gain a deeper understanding of the world around us.
That makes a lot of sense. And I gotta say, I'm already starting to look at the world a little differently thanks to this conversation. Okay, we've covered a lot of ground here today. We've talked about the science behind pendulums, the power of simulations, and this amazing world of open educational resources. But before we wrap up this part of our deep dive, there's one more thing I'm curious about. What if we took this observe, theorize, simulate approach and pushed it even further? I mean, what if we could use it not just to understand the world, but to actually, make it better?
That's a fantastic thought. And honestly, it's already happening in so many fields. Think about engineers using simulations to design like safer cars or more efficient buildings.
Yeah, I see what you mean.
Doctors are even using them to plan surgeries and test out new treatments.
Oh, wow.
And city planners use them to try and optimize traffic flow and reduce all that congestion we always seem to have.
So it's not just about sitting back and observing the world anymore. We can use these tools to actually change things, right? Make things better.
Exactly. It's about taking this scientific mindset, the one we've been talking about, and using it to make a positive impact.
I'm really liking this idea. It's almost like instead of just being like students of the universe,
Yeah.
we could become active participants in, I don't know, its evolution.
Haha, that's a great way to put it. And something that anyone can do, You don't need some fancy degree or anything.
That's reassuring.
What matters is that spark of curiosity and a willingness to learn and a desire to make a difference.
This whole conversation has been super eye-opening. We started with a simple pendulum, and now we're talking about the vast potential of this scientific method to not only understand the world, but to actually improve it.
I know, right? It's pretty cool stuff.
So to our listeners, why should they care about all this? What's the takeaway message here?
Well, the big thing is you don't have to be a scientist or, a mathematician to use this approach. It's a way of thinking that anyone can apply to, well, any aspect of their life.
Really any aspect.
Yeah, think about it. Whether you're trying to solve a problem at work or figure out a better way to manage your time or even just understand something that's always bugged you,
Mm.
this method can help you break it down and make sense of it.
So it's like we're giving our listeners a mental toolkit to help them understand the world around them, right?
Exactly. And the best part is they don't need any fancy equipment or anything, just their own curiosity and a little bit of effort.
And of course, a little help from open educational resources like the ones we've been talking about today, right?
Of course. Those resources are a game changer. They make all this information and these tools available to pretty much anyone who wants to learn.
Speaking of those resources, we should probably give another shout out to Open Source Physics at Singapore for providing, the amazing stuff that inspired this whole deep dive.
Absolutely. They're doing fantastic work in making knowledge accessible to everyone.
Couldn't agree more. Okay, I think we've thoroughly explored the world of pendulums today and, all the broader implications of this observe, theorize, simulate approach. We talked about the science, the resources, and how incredibly powerful this method can be for understanding, well, pretty much anything. But I can't help but wonder, what if we could use all this stuff to actually, build a better future?
I mean, that's kind of the whole point, right? It's all about using knowledge to create positive change.
Yeah, you're right. But I guess what I mean is, what if we took this whole observe, theorize, simulate thing and I don't know, made it even more proactive?
I think I see what you mean. Not just using it to react to problems, but to anticipate them, right?
Exactly. Could we use this approach to design systems that are inherently more sustainable or resilient?
Oh, absolutely. We're already seeing that happening in some areas. There are urban planners using simulations to design cities that are, more walkable and less car dependent.
Oh, wow, that's really cool.
And there are architects using them to create buildings that are energy efficient and even adapt to changing weather conditions.
So we're not just talking about fixing problems after they happen anymore, but preventing them from happening in the first place.
Exactly. It's about using our understanding of how things work to design systems that are, more in harmony with the natural world and more resilient to change.
This is blowing my mind again. I mean, we started with a simple pendulum, and now we're talking about designing the future.
I know, right? It's amazing to see how far we can go with a little curiosity and a willingness to experiment.
I couldn't agree more. So to wrap things up for our listeners, what's the big takeaway here? What do we want them to walk away with?
I think the most important thing is that this observe, theorize, simulate approach, it's not just for scientists or engineers. It's a way of thinking that anyone can use to understand and shape the world around them.
It's like a superpower almost.
Exactly. And the more people who have this superpower, the better equipped we'll be to face the challenges of the future, and create a world that's more sustainable, more equitable, more awesome.
Love it. Well said. Okay, I think that's about all the time we have for today's deep dive. Huge thanks to Open Source Physics at Singapore for the incredible resources.
Yes, thank you.
And to all of our amazing listeners out there, keep those minds curious, keep exploring, and most importantly, keep using that observe, theorize, simulate superpower to make the world a better place. Until next time, happy exploring.